Hey guys, welcome to today's class. Have fun.
Acid, base, and salts. An acid is a substance which produces hydrogen ion as the only positive ion when dissolved in water. We have organic acid, inorganic acid. Organic acid are gotten from plants and animals. Inorganic are gotten from inorganic materials or minerals matter. Example of organic, we have ethanol, amino, fatty acid. Example of inorganic, we have HCl, H2SO4, HNO3. Strong acid ionize completely in water to give hydrogen ion and anion. What do you mean by ionize completely? That means it separates completely. For example, as you can see, we have HCl separate from acid and what? Separate from hydrogen and chlorine. Weak acid ionizes partially in water. Physical property of acid. Dilute acid has a sour taste. It has a sour taste, just like unripe fruits. When you take your unripe fruit, they have sour taste. Acid turn blue litmus red. Concentrated acid are very corrosive, and you don't pour water into acid, you pour acid into water. Chemical properties. Acid reacts with base to give you salt and water only, which is known as what? Neutralization process. Reaction with metals. When acid reacts with metal, it gives salt and hydrogen gas. Reaction with triazo carbonate 4. It gives you salt, carbon 4 oxide plus water. It gives you carbon 4 oxide plus water. Uses of acid. Acid can be used as fertilizer, detergent, drugs in various industry. Now we have base. We discussed about acid. Now base. A base is a substance which will neutralize an acid to yield a salt and water only. Property of base. Physical properties of base. Base has a bitter taste. They are soapy to touch, and they turn blue litmus. They turn red litmus blue. Acid turn blue litmus red, while base turn red litmus blue. Example of base, we have sodium oxide, we have potassium oxide, sodium hydroxide, potassium hydroxide. Alkaline. An alkaline is a basic hydroxide which is soluble in water. Soluble in water. Reaction of base with ammonium salt will give you ammonium gas and other substance. Ammonium gas and other compound. Salt. A salt is a compound formed when all or part of the ionizable hydrogen of an acid is replaced by metallic or ammonium ion. From our example, you see we have HCl. Sodium replaces what? The hydrogen in HCl, and it gives us sodium chloride. Type of salt. We have normal salt, and we have acidic salt, and so on. Normal salts are formed when all the replaceable hydrogen ion in an acid has been completely replaced by metallic ion. For example, HCl plus potassium hydroxide will give us a salt which is potassium chloride plus water. Acidic salts, they are formed when replaceable hydrogen ion in the acid are only partially replaced by a metal. As you can see, you can still see some hydrogen in the salt. This is what we know. This salt is called what? Acidic salt. Now we have basic salt too. Basic salt are formed when there is an insufficient supply of acid for the complete neutralization of base. When you have insufficient supply of acid, you have limited acid. That is when you get what? Basic salt. We also have double salt and complex salt. Double salt are formed when hot concentrated equimolar aqueous solution of two simple salts are mixed together in the ratio of their relative molecular mass and allowed to cool. We have an example there. Complex salts contains complex ion. They contain complex ion. Uses of salt: you can use your salt to preserve food, etc. Water of crystallization. Many salts combine chemically with water to form hydrated salts. Hydrated salts contain a fixed definite amount of water known as the water of crystallization. So we can say water of crystallization is a definite amount of water some substance chemically combine with when they form salts from their aqueous solution. For example, copper 2 tetrahydrosulfate 6 combine with 5 molecules of water to form a hydrated salt. Calculation: we have 7.60 gram of blue copper 2 tetrahydrosulfate 6 crystal. Were heated to a constant mass, first at a temperature of 100 degrees centigrade and then at 120 degrees centigrade. The residue that was obtained at 100 degrees centigrade weighed 5.40 gram, and that obtained at 120 degrees centigrade weighed 4.85 gram. Calculate the stages of dehydration reached at 100 degrees centigrade and 120 degrees centigrade respectively. Solution: you bring out your value from your question. The mass of your crystal is 7.60 gram. Then the mass of dehydrated salt at 100 degrees centigrade is 5.40 gram. Therefore, the mass of water driven off at 100 degrees centigrade, you can also say the amount of water lost at 100 degrees centigrade is 7.60 minus 5.40 gram. It will give us 2.20 gram. Now, at 120 degrees centigrade, we have 4.85 gram. Therefore, the mass of water driven off at 120 degrees centigrade will be equal to 2.75 gram. We draw our table because the question requires us to bring out the stages of dehydration reached at 100 degrees centigrade and 120 degrees centigrade. Dehydration reached at 120 degrees centigrade. Mass of water driven off, that means the amount of water lost at 100 degrees centigrade, is 2.20 gram. We have expression X water represents what? Represents the molar mass of water of crystallization. Divide by the molar mass of your crystal will give us mass of water loss. That means mass of water driven off at 100 degrees centigrade divided by 7.6. 7.6 is the mass of the crystal. Now, what is the molar mass of water? 18. So we have 18s. The molar mass of copper 2 tetrahydrosulfate 6 is 249.5. You cross multiply, you have your x. So the value of x is 4.01. The number of molecule of water driven off is equal to 4.01. Therefore, copper 2 tetraoxosulfate 6 exists as copper 2 tetraoxosulfate 6 monohydrate at 100 degrees centigrade. That means it has only one molecule of water left at 100 degrees centigrade. Dehydration at 120 degrees centigrade. The mass of water driven off, the amount of water lost is 2.75 gram. The expression there just the same as 100 degrees centigrade. You have your what? The molar mass of water of crystallization divided by the molar mass of your crystal is equal to the mass of water driven off at 120 degrees centigrade divided by what? The mass of your crystal. So we have 18x divided by 249.5 is equal to 2.75 divided by 7.6. You cross multiply and it gives us 5.02. The number of molecule of water driven off at 120 degrees centigrade is 5. So therefore, copper 2 tetraoxosulfate 6 exists as copper 2 tetraoxosulfate 6. There is no molecule of water left. It lost all the molecule of water. Characteristics of some salts. Number 1, we have efflorescence. Some crystalline salts will lose parts or all of their water of crystallization when they are exposed to the atmosphere to form a lower dehydrated salt. This phenomenon is known as efflorescence and the salt is known as efflorescence. Example is the washing soda molecule. Washing soda molecule. When your washing soda is exposed to the atmosphere, it loses 9 molecules of water. 9 molecules of water. Number 2, deliquescence. Some compound tends to absorb so much water from the atmosphere that they dissolve in it to form an aqueous solution. Aqueous solution of the compound. This phenomenon is known as what? Deliquescence, and the substance are said to be deliquescent. Examples are sodium hydroxide, iron 3 chloride, potassium hydroxide, magnesium chloride, and phosphorus 5 oxide. Number 3, we have hygroscopic. Hygroscopic substances also absorb water when exposed to the atmosphere, but will not form solution, rather they become sticky. Examples are calcium oxide, sodium triisonitrate 5, copper 2 oxide, and concentrated tetraoxosulfate 6 acid. Number 4, drying agent. Drying agent are substance that has a strong affinity for moisture or water. Hygroscopic substances are commonly used as drying agents. Deliquescent substances too can be used as drying agents. A drying agent cannot be used if it reacts with the substance to be dry. It cannot be used if it reacts with the substance that is to dry. Common drying agents and the gases they dry. Drying agent 1, we have concentrated tetraoxosulfate 6 dries all gases except ammonium and hydrogen sulfide. Number 2, fused calcium chloride. It dries all gases except ammonia. Number 3, phosphorus 5 oxide. It dries all gases except ammonia. Number 4, we have quicklime, which is also known as calcium oxide, suitable for ammonium gas. Number 5, we have silica gel, suitable for all gases. Drying agents are commonly used in desiccator for drying substances. Drying agents are commonly used in desiccator for drying substances. Measurement of acidic and alkalinity. The pH scale. The pH scale is a number scale from 0 to 14 used to measure the level of acidity or alkalinity of a solution. A solution with a pH value of 7 is neutral. A solution with a pH value less than 7 is acidic, while one with a value more than 7 is alkaline. Acidity increases with decrease in pH value, while alkalinity increases with increase in pH value. pH refers to hydrogen ion concentration. The pH of a solution can be measured with a pH meter or by the use of universal indicator. A universal indicator is made up of a mixture of various indicators which work at different pH range. A universal indicator is a mixture of different type of indicator. So we say indicators are weak organic acid or base, which identify a chemical compound as an acid or a base. Universal indicator changes its color over a wide range from red through orange, yellow, green, blue, violet to purple. The pH of a solution can be measured accurately by using a pH meter. It can even measure the pH of a dilute solution as well as that of colored liquid. Importance of pH. Number 1, pH value are important in agriculture. Most plants grow well in soil with pH of 7 to 8. Number 2, the regulation of pH is important in sewage disposal, treatment of industrial water, and environmental protection of rivers. pH value are also important in medicine and several other industrial processing. Buffer solution. A buffer solution is one which resists change in pH on dilution or on addition of small amount of acid or alkaline. Buffer solutions are of great importance in medicine and biochemistry, where pH values are often critical and have to be maintained at a steady value.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We would love to help you further. See you in the next class.